that well, that
Sorry,
Python is
stop talking.
yeah.
Hello, welcome back. I'm here with Frederieke, who is a very experienced developer, more than 15 years of enterprise Java experience. And she has worked on a lot of technologies ranging from reactive messaging, Kafka, JAX, RS, JSON bindings, you name it. And I think she's not like I am afraid of snakes. Are you, Frederieke?
No, I. My sister lives in Australia, lived
Ah,
in Australia, and they have a lot of dangerous snakes there. So yeah,
okay, so we're
well,
gonna need a
they
lot of
are the snakes
courage.
to be afraid of. Actually, the snakes here in the Netherlands, where I live, are usually pretty friendly, except for that we have like the adder, which is a viper, and that one's poisonous, but it's so rare that if you see a snake in the Netherlands, you're counted lucky.
Okay, cool.
Hmm.
I guess it's the same in Sweden. We have like one venomous snake here. But I guess we're gonna need some courage for this presentation because there will be snakes and there'll be some live coding if I'm not incorrect.
Yes, I will try, and hopefully everything will work out just fine.
I bet it will. So take it away whenever you're ready. We're ready for you. So you can just
Okay,
start
I'm
presenting
ready.
and
Yes. Okay,
yeah.
cool. Let me just see how can I share my screen because I did that
I,
once before.
I hope if you hover the mouse over my face, for example, you get
Yep. Yes. And then yeah, that's there. Yeah. Okay. Share
yeah,
your screen. Okay.
yeah.
Cool. Share your screen. Yes, that should be working. Okay. Just hold on. Exit. Hold on.
We've had some issues with screen
Clear.
sharing, but I bet you can manage.
Ah, yeah. Everything will work. Yep. That's there. And I will share this screen. Share. And this like
Super.
a yes, it
Looks
works.
good. I can see
Okay.
terminal.
Yeah, okay, that's cool because now I'll just start the presentation.
Yeah.
So, welcome everyone. Not live like probably everyone hoped it would be, but well, still welcome everyone. This is my presentation about which is called sorry, my voice is is a bit cracky today. It's called Watch Out for Snakes: A Bite-Sized Introduction to Python. And it's basically intended as an introduction for Java developers or any other developer who would like to start with Python. And we'll see how we can avoid being bitten by the snake. That's actually the takeaway of the presentation, and how Python will eventually help you do cool things, right? So, so my name is Frederieke Scheper. I'm a Java architect and codesmith working at Ordina Jeter, and I heart Java and other conferences, especially tech conferences. I'm currently contracted by the Dutch Ministry of Justice and Security, and I have a passion for machine learning, big data technologies, and reactive programming. And we'll come back to the last bit of that at the end of the presentation, hopefully. And you can contact me on Twitter anytime you like. So just find me, FBA Scheper, and we'll have a good chat, hopefully, about anything about this presentation, Java, Python, or whatever that, that you were interesting, actually. But for now, let's just talk about snakes, or actually Python, from a Java perspective. Now, I'm just wondering, do you remember this? The classes like this. This is not my first Java, but this is the kind of classes that I have seen that people write. It says, no, it's static methods everywhere. Or something else like we have a rectangle, but it has an inert domain model. So basically you could calculate the area of the domain model and you could give it a method that gives me the area of the rectangle, right? And and usually you get all these handy utility classes that had all those methods that you could actually have written in your domain classes, right? So in this case, calculate the area of the rectangle using my first rectangle and calculate the width and multiply it with the height, right? Well, actually, what I see happening is that history is repeating itself with Python, or actually Java developers writing Python code. And the first thing that I'd like to give as a takeaway for you is let's just start with Pythonic thinking. And Pythonic thinking is thinking like Python developers, right? So don't try to write code as a Java developer, but try to write code like your fellow Python developers if you want to write Python. And the first and first and very important thing is always know which version of Python you're using. So basically, regularly run Python 3 -- version. And the latest version is currently version 3.10, and it has some really useful extra features. So you have to, another important thing is always follow the style guide. And PEP 8, so the Python enhancement process. So Python has its enhancement process like the Java has the Java community process. Python has the same, and the current recommendations are always in the style guide. Another thing, if you're coming from Java, is that you have to know the difference between bytes and str, which is basically the string in the Java string. And if you want to write out strings, which is a very common thing to do, just prefer the very latest versions. It's called F strings, F for format strings, over the C style format strings. And there's another way of interpolating which is also no longer recommended. And well, this is something that I found really intriguing. Please avoid else blocks after for and while loops. I think Python is actually the only language that that supports this, and I'll show you what this actually does if you add an else block to at the end of a loop, right? So first of all, so I'd like to walk you through each of these 5 points that I just gave away, like these, right? So avoid Python 2.x. There are still a lot of, well, at least in where I work, which is the Dutch Ministry of Justice and Security, we have like various images of various Red Hat versions, and it's often that you still see Python 2.7 hanging around. And please, please, please avoid it, because it's no longer supported. At least it's no longer supported in your machine. Red Hat still supports it, but please avoid it. Right? So what I just said about Python 3 -- version, just run it in your builds, right? So that you can see, oh, okay, there's a newer version. Maybe I should update my builds. And be aware of the newer versions that are available, because Python is really released a lot more frequently. Well, no more actually. It's released about as frequently as Java, and the latest version is Python 3.10, and they're currently working on 3.11. And actually, better error tracking, well, that sounds like something that is really useful, and it actually is. But for me, the killer version in Python 3.10 is structural pattern matching, which is something that Java is also working on. And this would merit a talk of its own, I believe. And explicit type aliases is something. Type aliases, just to be sure, types in Python are sort of a hint to a type checker, but there's nothing that really mandates the use of types, but this makes things even more safe when you're using the type checker. So it's always good to be aware of newer versions and just be aware of the Python version in general. So now let's just take a look at a few important things in the style guide that are different than we're used to in Java. And so the first thing is white space, which is really important because it's syntactically important in Python. So first of all, always use spaces instead of tabs for indentation. In Java, we had like the Sun coding standard, we have like the Google coding standard, we have like all these coding standards. And the general recommendation in Python is always just use spaces and use 4 of them for each level of syntactically significant indenting. And also when you have a really long expression, you can continue it with a backslash, and then please also use 4 spaces to show that this line is that the line is continued on the next line, right? And also, please don't make the lines, well, it's a recommendation, but never make lines longer than or equal to 80 characters. This is, well, yeah, well, it's just the way everyone writes the code. And in a file, functions and classes can be combined. You can also have multiple classes, and they should be separated by 2 blank lines. And in a class, a method should be separated by one blank line. If you do this, then people will already be really happy with you, because everything looks as they expect. And as I said, white space is really syntactically significant. So hopefully I will not be bitten by this significance in the live coding, which of all the really short demos that I've included in this presentation. So the next thing that is really important when you're coming from a Java is that you have to know the difference between bytes and so a string. So instead of instances of bytes contain raw unsigned 8-bit values. So let's just try this out, right? So I have this piece of code, right? So we have like A was the B means that it's a binary 8-bit value, and x65, that's the ASCII character 65, which is an A. So hopefully we'll just see if this works, right? So I'll try to paste this in here. So basically what we see here is I'm printing the list of A. So I'm listing 5 characters, 104, 101, 108, 108, and 111. And if I print the entire value, it says, oh, it's a binary string of hello. Oh, and we can also convert it to a string, and it's better to do it like this first. Maybe this helps. So now it's a string. So you can decode decode using an encoding, which is basically the same you can do with a byte array in Java, right? And when we print the list, we have like the list of characters. So this is a byte. This is an instant of bytes, and it has this. And as I said, this is the output that it was supposed to give. So a binary string of hello. And when you compare that with a str or string, instances of string contain Unicode code points. Oh dear, typo, but don't mind it. Which represent textual characters from human languages. So let's try this. Apropos, which has a list of characters also. So you can list out a string and you can list out a byte array, which gives us a list of the contents. And let's just see what the difference is between this and what we just had. So we'll just paste that same code in. This what I'm using on the right on my screen is, by the way, is a REPL, so read, evaluate, print loop, which is also available in Java since Java 9. So I'm really confident that you know this is. So it's actually JShell, which is the Java REPL. Now the interesting bit, if we print out the list from the Unicode string that we just have, is that it has like A, and this is kind of weird. It is a string which goes like a character back and then has the special character, right? And then a space, apropos. And we can also print the entire string, and then you will see what it has done. So basically, I'm trying to make this a bit bigger. So hopefully this helps. So basically what you see here, it has apropos. It's like the French. Apropos means it's the French. It's this is like something that is that we're currently talking about. So it's relevant. Apropos, it's relevant. And we can print the list. So now what we have, we can encode using the encoding the string to a byte array. Oh, sorry, yeah, I'm sorry. I'll be every now and then the light goes out here. That's for economic reasons, but it's really a nuisance actually when you give a presentation. So sorry about that. If you see me wave or just move a little bit, then it's probably because the light has gone out. What you see here is the byte array, the byte representation of what we just had, right? So we can also convert this back, and then we can convert that to a string. But so what is actually what you see here is like we have this string apropos, It's printed correctly with the special A with accent grave, and that's really important. So this is the output that was supposed to be, and that we just saw actually. So what's important to remember from this? So these string instances do not have an associated binary encoding, and they have to be converted using the encode method of the string. And bytes instances do not have a text encoding, and they need to be encoded using decode. And what you have to remember for the program structure is always use string types. Never use the binary string of the bytes instance, so the ones starting with B, and encode and decode at the boundaries of your application, right? So when you want to write out a text, a binary stream, that's the moment that you have to convert. The next important thing to that you see in many programs is writing out strings, right? Interpolating strings, the same that we do in Java a lot. And the original option that was provided with Python was the percentage operator, which originates from the printf function in C. So basically, you have like a binary and a hex value, and you can print it out. And what you see here, I'll just try this as well, and then you can see what happens, right? So the conversion of this binary string is 187, and the conversion of this hex string is 3167. So it's converted to a decimal, and this is the percentage operator. So basically, you have this string that is used as a format string. You have the percentage operator, and then you give it a tuple. A tuple is something that is not in Java. It's something that I actually do miss, especially when with return values of methods. When you want to return more than one thing, then you have to make a class out of it that you have to return. You can't just return like a tuple of things. So basically, this is the C style formatting, and it's simple and powerful, and well, yeah, and it's still used a lot. But there are a lot of known issues with this operator. The first thing is if you change the type or the order of the data values, then that may cause type conversion errors. Remember here, if you had like the percent, so basically if A would be a string, in this case, it would go right, of course. If you write here B colon A, then it would just say binary is, but it's not the value of the binary, it's the value of the hex. And in the hex, it would say the hex is the value of the binary, which is, so if you reverse the order, then you have a problem, right? And may also cause type conversion errors if you have like strings and numbers in your tuple. And eventually it becomes really difficult to read. And verbose, because if you want to write out this binary value, you want to write it out many times, then you have to repeat it for each and every time that you want it, right? So, and you have to report it in the correct order as well. So this, well, at the after if you have just a few, then the percentage operator just works fine. But when the operator becomes more complex, then it's getting out of hand pretty quickly. Now, to resolve this, with Python 3, the format built-in or the string.format method were introduced. And let's just take a quick look what this does, right? So basically, let's just try it out. So what you see here is you can do like multiple assignments in one line. Just don't do that in your code, please. It's just for me to fit everything on the screen, right? So please don't do this. It's just to help you. So what we see here is this is like the format built in. And this is the format string. So the order is reversed, which is really convenient, of course. And we have a float. because A is a float, so we're formatting the float A with this format string, and the comma means that the thousands comma is added, like here, and so and this is so point to F. Oh, sorry about that. Point to F means so we don't want to see like the 7, 8, only the 5, 6, and please round it. So that's what the format built-in does. Right. We can also use the string.format method. So now what we have is this is the format string dot format, and then add the parameter a. So now we have like there's no yeah, sorry, that's just wrong. I thought there would not be a thousands, but apparently there is. But then again, 0.3f. I'm just a bit surprised actually what this does, because I expected this to look slightly different, but then again, you can use this, right? And maybe the best way of using the format method is like this. So what you say is, so you can also use things between these brackets, right? So, and it's the index of the parameter. So you can have format name and then comma another name and then comma yet another name, etc., etc. And then it would be like format 0 loves Python, C1, etc. Right? So this is like the index in here. So we can also do this just to demo, comma whatever. Oh dear. And then C1. And hopefully like that, right? Okay, so this is like the new format that was introduced with Python 3. And of course it's some improvement, right? It's slightly better than the C* formatting using the percentage operator, but if you change the type or the order of the values, you may still get type conversion errors, and it still becomes difficult to read, although it's less verbose, and it allows reuse of index variables by using like this syntax. But what came in Python 3.6 is the interpolated format strings, or the F strings. And I think this is really awesome. And this is the type that you should use, that everyone should use from now on. So please remember, do this. And let's just see what happens if we try this out. Oh, sorry, key, right, places is 3. These are the values. So you can have like my var is and the value, key and value. You can also format it. And what it does is actually, you see that here it has like these extra spaces because we wanted to have like 10, a length of 10. And what we also can do is, which is even more powerful, is in the format string, you can use like the places in itself. And now it says we're having like 3 decimal values here, right? Which is just awesome, I think. So this is string formatting, and this is the kind of formatting that everyone should use from now on. It's really powerful. So this is the preferred solution. Hey, yep. Oh, I was expecting to say what the advantages were. So the C* format string is the traditional, it's still the most common, but it does have many gotchas and verbosity problems. So the string format method should be avoided because it repeats the mistakes of the C* format strings, and there's a better alternative. So F strings is the newest syntax for formatting values into strings. It solves almost all the problems with the C* format strings, and it also allows arbitrary Python expressions embedded within the format specifiers, which is really, really, really powerful. So the other thing about Pythonic things that I would like to share with you is please avoid else blocks after for and while loops. So let's just try this piece of code as well. So you have this for loop and it has an else, and there's a while loop and it has an else. And let's just see what this does actually. Oh dear. So it actually what happens is we loop through the range, and at the end it still prints the else block text, right? So for else block. Well, I think this is really surprising, right? And the same actually happens with the while loop. So at the end of the loop, it just executes what happens at the end of the inside the else block. So while false, this never runs, of course. So at the end, it always runs the while else block. So it's just bizarre, right? I think this no one really expects this to happen. So the takeaway in this case is, please don't do everything you can do in Python. And that's of course the same with every language. Just think rationally, what would be the expected way of doing things? So let's have a quick wrap up of the Pythonic thinking. So first of all, you need to know which version you're using, follow the style guide, know the difference between bytes and str, and basically always use strings and use bytes only at the edge of your program. And when you want to write out things, please use the F strings and don't use the C style format strings or the other method. And of course, don't do everything you can do, so you need to avoid these. Now, stepping up, you also have functional programming. Like Java, Python is not a functional language, so it's mostly imperative programming. Immutability and constants are not supported, but you can indicate that a variable should be constant. So like here, from typing import final, const name is final is Frederieke. So this is like the type and print the const name. And let's try this out. Just hold on for a sec. And then after, so you can do this, and I can still say, oh, okay. And it says Frederieke too. Well, right, so there's no such thing as a final in Java, but it's used by static type checkers like MyPy. And this is the closest thing you can get to something in Java. Now you can also pass functions as arguments to other functions. So basically we have here a higher order function. So it says greetings from Frederieke, and you pass it a function in it. So it's callable with a list of parameters, and that's just, in this case, it has only one parameter, so string. It says string, and it gives back a string. And you pass it the full function. So basically the result is the full function of greetings from Frederieke, and it returns the result. And then we have like fun1, which returns it into a lowercase, and fun2 returns it into an uppercase. And let's just try this out, just for fun. Oh, crikey! You always have this. Okay, so please, hopefully this works. Yes. No. Right. So basically, what are we doing? So basically, we're calling the fun function, and we give it the fun1 function to operate on. Basically, so it says, so it's operating the two lowercase on greetings from Frederieke, which is exactly what you would expect. So let's now try the second. Oh, I can of course still, it doesn't matter. So now we pass it the second function, and it makes it into uppercase, right? So this is really cool. So you can do functional programming in Python using the higher order function, and you pass the functions as parameters. And this just works, so it's excellent. And stepping it further up, you have like decorators, which is really awesome. If you want to, for example, this is like a logging function where the print log it, then you would actually log the arguments or whatever you do, and the method that you're calling, which you also have to your disposal. And we have like the takes inster, and let's just see what this does, and then I'll walk you through it, and hopefully I can just copy paste this in one go, because otherwise. Yeah, okay, so this works. So basically this is the add logging. Sorry, light goes out again. Hold on for a sec. Yes, it's back on, thanks. So basically we have like, we're calling the takes int string. We give the parameter 1 and the parameter test. And this function returns x plus the length of the string. So basically it should return like 5, which it does, right? And now we try to, and we print the value that is returned. And and before it's called, the add logging method is called, which runs the logit method, right? So and you can see that this works because this test like another thing. And log it, right? And we could also now, well, you could expand this in any way you want. This is really powerful. right? So I think there's nothing in Java that's comparable to this in terms of its power. Yeah, you can do it with reflection, of course, but it takes a hell of a lot more effort. If you need Java or Scala-like connections, my recommendation is please use PyFunctional. So we'll just try this out for a second, and then I'll continue on. Like, hopefully I have still some time left. Right, because right. So this is the output 40. You just saw it. Basically, what you have, like they have a sec, which is a sequence. It has it's inspired by Scala, so it has you map every value. This is what you see here. Map every value times 2, and then if the result is greater than 4, then filter all the other things out, and then we reduce it. So basically, it should add like 6 and 8. So 2 times 3 plus 2 times 4 is equals to 14, right? So that's the output. But hold on. Doesn't Python have its own collections? Yes, of course it does. There's like lists, tuples, sets, and dictionaries. We already saw the tuples. So basically we have like, this is the list. It's declared in square brackets. It's mutable. It can support duplicates. You also can access it using the indexes. For time's sake and to have enough time for questions, because I think, let me just check. How much time have we got for the conference? Well, I'll just, well, this is the output. So John, USA, oh, no, don't mind the apostrophe that has been converted. I'll just show you that this is actually really working. So, so John is in USA, and you can print the type of the list as well. So we have this, but the important thing to remember about lists is that it's mutable, and of course, like any list, it can have duplicates. And in that sense, it's comparable to Java list. We have the tuple. You declare it in round brackets. We already saw this in the percentage operator in the C-style format interpolation. A tuple is always ordered, and it's immutable. So this is one of the few things in Python that's actually immutable. And of course, you can have duplicates like in my tuple could also be Mustang, Mustang, Ford, Ford, 1964, 1964. Would not be a problem. Basically, a tuple, you can compare that to the result of a, if you have like a relational database, then a row is basically a tuple, right? And you can print this, and let me just, and it prints like this. So this is the tuple, right? Mustang, Ford, 1964. And it's ordered in the sense that but it's not sorted, right? So the order is in that you use to create the tuple is remained. Just like the list. Oh, sorry about that. That was just one too fast. So the same here. A list is mutable with duplicates and can be accessed right using indexes. So here also, it's never going to happen that John and USA are switched, right? So you get that always get that in the same order back. And the same is with tuples. They are also ordered and they are immutable. Sets. Python also has sets. So it's unordered and mutable, and it doesn't. You cannot have duplicates in a set, which basically the essential characteristic of a set, of course. And you also cannot have indexes in it. And so in such a sense, you can compare it to Java sets. Oh, hey, there should be an example, but there isn't. Sorry about that. I probably deleted that. Well, you know set, hopefully. So I think that apart from tuples, dicts is also something that is really, really common in Python. So it has like, you declare it in square bracket, it has key values, and it's mutable. So let me just print this dict thing, which is, dict is basically a shorthand for dictionary, of course, hopefully. So let me just try this out, what happens. No. So you have like this is printed slightly different as you see. So basically what you see here is it has key value pairs. So the model is of has a Mustang, the brand is a Ford, and the year is 1964. And when you print it out, it's printed out like this. So model is Mustang, brand is Ford, and year is 1964. So what you see here actually is that the value, the type of the value, there's no such thing as an enforcement of the value of types here, right? So you can have because you can compare this to Java maps. That's probably that you already realized. But in a Java map, as a rule, you always give the key and the value, give it a type, and then the type is enforced. But no such thing happens in Python. You can define the type of your dictionary, but as I said previously, this will only be enforced when you have like a type checker, and otherwise it's just documentation. Right. So it's comparable to Java maps. But there are a lot more collections actually in Python than these four. And they are in the collections module. So there's a name tuple, which is sort of a tuple where each element of the tuple also has a name. So it's sort of like a key value in a tuple. We have a deck, which is a shorthand for the double-ended queue, which actually also exists in Java, and that makes it easier to add elements at the beginning or at the end of the list. It's a chain map. We have like a counter. I'll show that in a second because I've got a short demo about that. We have like an order dictionary. Actually, since Python 3.6, I think that the dict is ordered by default, but I'm not really sure. So we have like a couple of extra collections which have some specialties, right? So let's just show the counter, how this works. Oh dear, let me just see if I can get this. From collections, import the counter. So we have like a list of ones and a two and threes and fours. And now give me a counter of this list. And print it out, and what it says is we now have a map of all the values and the times that it's counted. So there's like 4 ones, we should have like 4 threes. Here are 2 and here are the other 2 threes, and of 4 we have 2, which is correct. Here is 1 4 and there's the other 4, and of 2s there is only 1. So basically what we now have is a map of, so the counter returns a map of the values inside the list, and with keys and values counted. Right. So some useful extras if you need them. Well, I think personally, because as I said, I love reactive programming and I love functional programming. And as such, I believe that the Python collections, the default collections, do have limitations in the sense that when you want to use them for functional programming, right? So for imperative programming, they're absolutely fantastic. Yep. But when you want to use functional programming, then you want to have like immutability. And this mutability of the collection of most of the collections, actually only the tuples are immutable, of course, but this mutability makes everything difficult to parallelize because you never know what's happened in the meantime. Also, I think that they're actually not so readable, and when you use lambda functions, I think they're pretty difficult for new developers, right? And that is why I really love PyFunctional, which is inspired by the Scala collections, Spark, RDD, and now data. I'm supposed to know what an RDD is, but I'm at a loss for words. I don't know anymore what the RDD in Spark was actually. And Microsoft Link, which is Microsoft Functional Programming. PyFunctional really makes creating data pipelines easy. So let's try this out, this sequence, because we can. Right from hold on. Hold on, I'm doing something wrong here. Just give me a second. Right, from function import sec. It's basically what I wanted to do. Right, so with like a sec, when we can map this with a lambda functions every time times 2, and then reduce it like this. So this is the lambda version, and this is actually slightly different from the syntax that I used previously, which was like this. I'll just repeat that for a second. It's not actually. We can also use like the x and then the arrow function if you want. So we still have like the map and reduce function, right? Where we add. So what happens is we multiply 1 by 2, we multiply 2 by 2, and multiply 3 by 2, which is the same as multiplying 6 by 2 is 12. So 2, 4, 6, and then we reduce by adding them together, and that gives 12, right? But the goodness about a functional PyFunctional is that a sec, everything in PyFunction is immutable. So you cannot change the sec itself that you have here. You have to use a function to do something with it, right? And then you get another sequence. So basically what happens here is sec.map. This should actually work. 2, 4, 6, right? And we can also dot filter lambda, sorry, lambda x greater than 2. Right. So now we filter this one out because that one. And each and every operation gives us a new sequence which is immutable in itself, right? And that I think that is really good. I'm sorry about this. I wasn't there. I was supposed to be like here. So PyFunctional. Okay. So PyFunctional, it was inspired by the Scala collections, the RDDs, and Microsoft Link. We have like the chained operators. It has a feature complete API. You can also read and write text and JSON and whatever things kind of fast. So it's really awesome. And it's also supports like the parallelizing functions. So if you have multiple cores and everyone has them, then it can and will parallelize them. So wrapping up for today, Python really is different from Java. So please don't write Java code in Python. Please be aware of all the the pitfalls and the style guide. And remember that apart from imperative programming, Python does support functional programming. It has its own collections, but in my personal opinion, these are vastly improved with PyFunctional. And you can also have like, which I'm not demoing, you have streams, aggregates, you can join. So it's really awesome. PyFunctional. If you want to do something functional, use PyFunctional. And I think, but that's my opinion, Python is really cool, even for Java developers. So now I'm open to questions.
Great. Okay. Thank you for a lovely presentation and a quick toe dipping in Python for Java developers. I have been monitoring the chat and the Q&A, but we don't have any questions yet. Are there no tuples in Java? I thought they had tuples nowadays.
Well, what I'm using is, but we're still in my organization. We're still at Java 11, which is limited, which is another Red Hat limitation because the you need newer libraries for Java 17. So we cannot migrate to Java 17 yet in most of the environments except the Dockerized environment. So on the Kubernetes cluster we can. But we haven't because we cannot, because Jenkins in our environment is running on Red Hat, and well, then you still have the catch-22. But what I'm using is the org Java tuples, which does support the tuples, and you can, well, yeah, it's a bit difficult, but well, as I said, that's the thing I'm using currently when I need tuples.
Great. We have about a minute left. What would you say is the hardest thing switching from Java to Python? What's the
The
hard thing to get?
hardest thing, I think the hardest thing is actually writing the code look like Python code. And and Python developers, other Pythonists will become really grumpy when your code doesn't look and feel like Python code. So that's basically why I started with this. Please write code that's Python code, right? So
Yeah.
yeah.
Yeah. I agree. When I started writing Python, I was kind of anti PEP 8, like the syntax formatting. But when you get your head around that, it actually has significant white space. You start
Yeah.
loving the formatting tools and
Yeah.
the static type checking.
Yeah.
Cool. Thank you so much for a great presentation. I hope you
Okay,
guys
you're welcome.
have enjoyed it. And
Yeah.
thank you so
Okay.
much. We'll see
Yeah,
you
okay, you're
in the next
welcome.
session.
Thank you. Okay.
Yeah.
Well, bye then. Have a great
Bye.
day, everyone.
Yeah. See you in 15 minutes for the next
Okay.
sessions. Bye.
Yes. Okay, bye.
I'm just gonna stop the stream then. Oh, I love these toe dipping sessions. They're great for just starting to get to know stuff.
Yeah, exactly. That's what I thought.
Yeah.